So here's section 0.6. All right, so we're going to talk about what a matrix is. First and foremost, a matrix is a rectangular array, right? That's what we call it. It's a rectangular array. An array is something that has rows and columns, okay? A matrix can have variables or constants. And like I said, it's arranged in rows and columns. And the way we write it is we enclose them in brackets. So you either do square brackets like this. This is more common. In textbooks and print, you'll also see something that looks like this here, where you've got, large parentheses. But when we're writing, the closed brackets, usually are the way we do it. Okay, so like I said, rows and columns. Each value is called an element. Okay, so in here you have 1, 2, 3, 4 by 3, 12 distinct elements here. All right, there is a specific way of how we refer to these elements. Remember, in matrices, when you have rows and columns, the precedence to label and to name is always rows come first, columns come second. Okay, so whether you're describing the matrix or you're calling out an element, it's always rows first, then columns. So here, this has 1, 2, 3 rows, right? And this has 1, 2, 3, 4 columns. All right. We say this is a 3 by 4 matrix. That's how we give the dimensions. Okay. So the dimensions is basically the size of the matrix. All right. And if it has m rows and n columns, m and n are the letters we use for the sizes of these matrices. Then we say it's m by n. So if you switch it around, right, n by m, then it's a completely different matrix. Okay, so in this case, this one, m by n, is 3 by 4. Okay, this is m, this is n. So do you see how if you switch those around, it'll be a completely different matrix? It'll have 4 rows and 3 columns. It'll be like that one lying on its side. All right, so they're not interchangeable. Okay, let's talk about the elements. By the way, another word for element in a different book may be entry. Okay? So how we label the element is the same way. So basically, if you look at this element, the value of it is -1. The position of it is this. Okay. The entire matrix here has a name of capital A. So we name matrices using capital letters. And then this specific entry will get a lowercase a, lowercase of whatever the matrix name is. And then you do row, comma, column. Okay. So what's the row here? This is the second row, first column. Okay, 2, 1. This, you're naming the position of this. So basically you're saying which seat is that student sitting in. Okay? All right. So let's do here, it says use A to answer the following. What are the dimensions of A? What do you guys think? 4 by 1, 2, 3, 4, 5, 6. Okay, so always go down first. You have 4 rows, 1, 2, 3, 4, and then 6 columns. So this is 4 by 6. Okay, and now find A, 2, 3. So little a, second row, third column, 0. Okay, so so if it's single digits, normally they don't put commas. Yeah, so then when you go into like the 11th row, right, instead of doing like 11, 21, 11, comma 21. Okay?
So when we're writing it, you want to write it like this?
Yeah, I have to say, don't stress too much over that because this is like, I'm never even going to ask you. specifically. Like, you know what I mean? Like, this is such small potatoes. Don't worry too much about it. Whether you put a comma or not, I really don't care. Yeah.
Wait, how did you get 0? Didn't you go up to
No, this is not like slope. So this is the second row, third column.
Yeah.
Okay, so first row, second row,
I just
and now 1, 2, third column. Okay.
Like -3, 0.
Right, no, we always start top right, top left. Okay, what about A3, 5? 5. What about A4, 6? 11. And what about A1, 2? Right. Okay. All right, so matrices with special names. A row matrix, guess what? It's a matrix with one row right here. So the dimensions here are what? 1 by 4. Okay. A column matrix, oh my God, that's a matrix with one column. So what are the dimensions of this one? 2 by 1. A square matrix, same number of rows as columns. So this is a 2 by 2. It could be a 3 by 3. It could be an 8 by 8. It could be an n by n. Okay. A zero matrix is a matrix in which every element is 0. An identity matrix, does yours say a square matrix?
Yeah, but for the other one.
Oh, exactly. Yeah. The 2 by 2.
The 2 by 2 one.
Yeah.
That's about.
Yeah, someone yours says.
Yeah, I had modified it, but I guess it didn't save. Okay, well, all right, it's a matrix in which every, oh, no, never mind, we're right. Every element in which every element in the main diagonal is 1. Okay, so what on earth is the main diagonal? So if you start here, 1, 1, and if you go down this is the main diagonal, all right? So every element on the main diagonal is 1, okay? And here's where I had modified this, but it didn't save because my computer shut down and I didn't catch this one. Every element on the main diagonal is 1, and the rest are zeros. Okay? Yes. I'll tell you later. All right, matrix operations. All right, so adding and subtracting are very, very straightforward. One thing you have to watch out for is matrices can only be added or subtracted if they have the same dimensions. All right? So 3 by 4, 3 by 4, 5 by 9, 5 by 9. Otherwise, you cannot add them. And you'll see why that's the case. The way you add matrices is this. So once they have the same dimensions, what you do is you add corresponding values. So look at this one. This is element 1, 1. Here, this is element 1, 1. You add them and it makes this. Okay? So this one is element 1, 2, 1, 2. You add them and it makes that. All right? So you just basically add corresponding elements. Subtracting, same exact situation. C here is element 2, 1. Here you subtract with 2, 1, and it goes in 2, 1. Okay, so let's do one here. We're going to add A plus C. All right? You can't. Not possible. They don't have the same dimensions. B minus A, though, that we could do. So B is this minus A is this. Now, the product, the difference, right? So the resulting matrix is going to have the same dimensions, 2 by 2, right? So now, 10 minus 2, 8. Negative 2 minus 5, negative 7, right? Negative 3 minus negative 1, negative 2. And then what's the next one? 16 minus 3, 13. There you have it. That's it. Straightforward. Multiplying is not as straightforward, but fun nonetheless. Maybe a little more fun. Okay. All right. So a matrix has different characteristics than regular numbers, right? So the things we can do with regular numbers are not the things that we can do with matrices, all right? So adding and subtracting are different, multiplying and dividing, those are different. Now, so a matrix is a completely different phenomenon. Okay, so what about a scalar? A scalar in the world of matrices is what we know as regular numbers, okay? So scalar multiplication is when you're multiplying a matrix by a regular number. And so basically all you do is you multiply each element by the value of the scalar. Super, super easy. You have a 3 by 2 here. You're going to end with a 3 by 2. And all you do is multiply every single element by -3. So we get -3, and then next to it, -15, 0, 6, 18, -12. Okay? That's scalar multiplication. Okay. Now, these properties that we have used for numbers also work for matrices. Commutative property is the same. Associative property is the same. So if you're going to add 3 matrices, the order in which you add them doesn't matter. Distributive property works the same way from the left and from the right. So let's do this one. Here we have 3a minus b. So you have to subtract a minus b and then multiply by 3. All right? So let's do that. So this is going to be 3. Okay, so what's the A matrix? This. Minus the B matrix. Okay? All right, so let's just do that very quickly. So 3 times what? 5 minus 1 is 4. Tell me, -2, and then what? 1, -3. 3 plus 1 is 4. 2 minus 6 is -4. So we get 12, negative. Okay? Yes? Huh? It is easy. It's very straightforward. This is why it's in chapter 0. It's going to get more interesting, I promise. I'm sorry about this. Yeah. Okay. Solving matrix equations. You can solve equations with matrices just like you could solve equations with numbers, except if I'm dealing with numbers, 3x minus 6 equals, whatever, 10, then when I solve for x, x will be a number, right? Okay, well, if I have a matrix equation, then when I solve for x, x will be a matrix, right? So your answer is a matrix, not a number. Okay, to solve matrix equations, you algebraically solve the equation for x, then substitute the matrices. Okay, so take a look here. I got A, I got B. I need to solve this for x. Okay, this is the equation we need to solve. So you treat it just like an algebraic equation. So 2x minus a equals b. 2x, notice x is a capital letter, b plus a. So x is half b plus a. Okay?
Why is it a capital letter?
Because it's a matrix. It stands for a matrix, not a number. Okay? Remember, matrices always have capital letter names. Yeah. So then you're just gonna put in half b plus a, right? And it's gonna be just like the other one. I'm just gonna set it up but not solve it. Hang on. So it's gonna be half b. I'll take your question in a second, Zach. Okay, so that's x, and then when you do the math here, x is gonna be a 2 by 3 matrix. Do we need to go over the math of it? I think you guys are okay, right? Okay, Zachary, question. We're going to move on to the next section, but I just want to point out here, this is not a typo. This is the page number. The page number is P27. It's before chapter 1. It's before page 1, okay? So it's like the first couple of pages in the book. This is, all right? So don't go to 27, go to P27. It has to be matrices. So many times people have done homework from a different page. Okay, now for the good stuff, okay? Now for the good stuff. No. Linear systems and row operations. Okay, so do you remember when we would solve systems of 3 equations with 3 variables and it was like that, you know, page long, whatever? Okay, so now we're going to do the same thing with matrices. Yes.
Oh, I
Yes.
love that.
Okay. So one thing, okay, so the process we use is called Gaussian elimination. Gauss was a physicist mostly. So he did a lot of work with magnetism. In fact, there is a unit for magnetism. There are 2 units for magnetism. One is the Tesla and one is the Gauss. Basically, 1,000 Tesla is 1 Gauss. So it's how strong a magnetic field is. So Gauss did a lot of work with magnetism, and then a lot of stuff with matrices. So we use his method. It's called Gaussian elimination. And basically what we do is we use either substitution or elimination, just like you know. And we convert the system of equations into an equivalent system, okay, in triangular form. So take a look here. This is a matrix. This is a system of equations in triangular form, right? So the last variable, the last row just has z, then y and z, then x, y, and z. Okay. There are 2 names for this, triangular form or row echelon form, and this is called Gaussian elimination. Okay, one thing I need to stress here. All of these bold terms, they apply to the equations and the matrices. Often my students confuse it and they go, oh, Gaussian elimination, that only works if you have X, Y, Z, and then something else that only works if you have a matrix. Not true. This works for everything. I will keep stressing this over and over. So basically what we do here, I also want to emphasize that the leading variables, once you have it in this form, are all 1. Okay? All right. So these are some of the operations that you could do, and it's like free of charge. You could interchange any 2 equations. You could multiply one of the equations by another number. You could add a multiple of one equation to another equation. Okay, how do we write a matrix in a system of equations in triangular form? Okay, so first, this is a little like step-by-step guide for you. First, eliminate the x term in equation 3. And then we're going to eliminate the x term in equation 2. And then we're going to eliminate the y term in equation 3. And then make sure all the leading coefficients are 1. I'm not going to read through this because I'm just going to go into this and just do this. Okay? All right. So first and foremost, can we look at this system? I'm going to do it using, I'm going to do it with the variables in there first, and then we're going to do it using matrices without the variables. Okay? All right, so do you see how we have 3 rows here? Look at the first row. We can divide everything there by 5, right? So let's just divide everything by 5. So the way we're going to do it is we're going to do, so 1/5 times row 1. Okay? Yeah. I'll try to write a little bigger. Okay, so here we're going to get x minus y minus z equals 7. Negative x plus 2y minus 3z equals negative 12. Copy, copy, copy. Okay, so basically if I want to get triangular form here, then I have to eliminate anything under this main diagonal, right? You see how this is the main diagonal? So this negative x, the 3x, and the negative 2, I have to go away. Of course, you can do it in any order that you want. However, based on my experience of having done this since, like, I don't know, the 90s, okay, this is a very efficient order of doing things. So first, we're going to eliminate the x term in equation 3, this 3x. How are we going to do that? By replacing equation 3 with the sum of multiples of equation 2 and another equation. Okay, so here's what we're going to do. I know it sounds a little confusing, but here's what we're going to do. Okay, so this is what I want to get rid of, right? Now, look at this row, this column of x's. How can I make the 3x go away? Multiply, It's just like what we did before, similar. Multiply by this by 3 and add them. Can we do that? Okay, so here's what we're going to do. 3 row 2 plus row 3. Okay? So am I changing row 1? Am I changing row 2? No, why don't I just copy those down? I'm changing the circled one, the 3x. Yeah, that's what I have there. I know it's tiny. Okay, so I copy down the stuff that I'm not changing. Now this is going to get replaced. So here's what I'm going to do. 3 times row 2, so that'll give me, this is my scratch work here, negative 3x plus 3x, 0. Okay, then negative 3 times, 3 times this one, so 6y minus 2y, positive 4y. Is that right? Okay, so what I'm doing is 3 times row 2 plus R3. So I take this, 3 times this plus that, right? That's negative 3x plus 3x. Is that right? Now I'm going to do the same operation to this. 3 times this is 6y minus y. That's 4y. Yeah, because I get a positive 4y. Right? So now, 3 times this is how much? Negative 9z plus 7z, negative 2z. 3 times this is negative 36 plus 30, negative 6. Right? So basically, whatever you've written here, you have to do that operation for each of these elements. Now, okay, one down. Now I need to get rid of, which one does it say to get rid of next? Huh? The one in equation 2. So next I'm going to get rid of this one. All right, so again, whatever you're not changing, write it down. The 0, I'm not going to write it, so it's just 4y minus 2z equals negative 6. We'll do that later. I don't want to, we'll do that later. You can. I'm going to do it later, okay? Here, how can I get rid of this? Combine it with the first equation, right? So what you do is you look at its row. What can I multiply here and add to this to get rid of this? Well, what I can do is row 1 plus row 2. Is that right? Row 1 plus row 2. Always keep track of what you're doing so you can check your work later. So x plus this is 0. Now, row 1 plus row 2 is plus y. Then you do the same operation with the z's. Row 1 plus row 2, negative 4z. Row 1 plus row 2, negative 5. Huh? Negative z plus negative 3z. Okay. Next. Okay, now I have a 0 here. Woohoo, I'm almost there, right? Now, what else do I need to get rid of? The 4y. This one. Okay? All right. No, because look at how it needs to look. The first one has x, y, z, then y, z, then z. Okay? Now I need to get rid of the 4y. Okay, so this went away. So I'm almost there. I just need to get rid of the y. And this order is the best because now the 4y don't look any further than the second row. The reason why I like to do it this way is because of that reason. When I get to the last one, don't even bother with the first row. You're always going to combine it with the second row. Okay, second and third row. Okay, so now how can okay, so the first and second rows are not changing. Let's just copy those down. I have x minus y minus z equals 7, y minus 4z equals negative 5. Okay. Can I do this 4y now? So how am I going to do that? Right. So you could do two things. You could do negative 4 plus this, or you could do 4 times row 2 minus this. Which one do you guys want to do? 4 minus row 3. Okay, so here's what we're going to do. 4 row 2 minus row 3. Here, 4y minus 4y, 0. What about here? 4 times this is negative 16 plus 2, negative 14z. And then 4 times this is negative 20 plus the minus, so plus this. So negative 20 plus 6 is negative 14. Okay? Now you need to go and make sure that all of your leading coefficients are 1. I don't have a problem here. I don't have a problem here. Here, I'm going to divide by negative 14. So R3 over negative 14, and we're going to get that z is equal to 1. So now this is in row echelon form. Huh? They're the same. They're synonyms. Okay? So this is in triangular form or row echelon form. Yes. So to solve, we work backwards. It's called back substitution. That's the term. So z is equal to 1, and now y minus 4z is equal to negative 5. Y minus 4 times 1 is equal to negative 5. So what's y? Negative 1. All right? And now x minus y minus z is 7. So x plus 1, right, minus 1 is equal to 7. How much is x? 7. Yay. So finally, here's what we have. Okay? All right, we're cool? It is long. It's, especially like when I'm explaining and things, it gets longer. We have to do that in section 4. So in this lesson, in this chapter, we're going to learn every single way of solving matrices. Okay? All right. Now, this is nice and cool and fun. But you know what? Those variables are just placeholders. you're just taking them along, but you're not really doing anything with the variables, are you? All of the operations that you're doing are on the coefficients. So just the 3 and the -2 and the 7, and then the x, y, z, they're just sort of like tagging along. So then what if we could erase all of the variables and just leave the coefficients and just work with the coefficients? Well, that's how you can solve this using matrices, right? So using matrices is the same exact thing. You just get rid of the variables. You just have the coefficients. So when solving this, we can use what we call an augmented matrix, all right? So here you've got the system of equations right here. This is the same one that we just solved. Here's the augmented matrix. So the augmented matrix has on the left-hand side all of the coefficients from here. 5, -5, -5, and so on. Do you guys see that? On the right-hand side are the, what do you call these? The constants, right? So these are the constants. And then we put a dashed line in the middle to separate them, or it could be a solid line. It's not a big deal. Most of the time I put a solid line. Okay, so that's called the augmented matrix. And then the coefficient matrix is just the one on the left-hand side. Cool? Okay, so check it out. You can do the same thing that we did here for matrices. Okay? It's still called Gaussian elimination. It's still called putting it in row echelon form. Okay? So, yeah, it's the same exact thing. So what's row echelon form? Row echelon form, basically, the first here, leading coefficients are 1. Everything underneath is 0. All right? And it is possible in row echelon form to have a row of zeros at the very bottom. Okay? All right. So is this one in row echelon form?
Yes.
Yes. Yes, because the leading terms are 1. Everything underneath is 0, so yes.
So is if any of the conditions from here, you just have to have one of them to be in your echelon form, but you have to have all of them.
The main thing is, okay, so like this one, for example, is this in row echelon form? No. Yeah, there are some leading ones. So that row of zeros is misplaced. If you were just to put that underneath, then it would have been good. But the way it stands now, this is a no. This one, leading coefficient of 1s, and then you have the zeros placed correctly. So that's pretty much what it needs to be, okay? So this is yes. Okay, tips and tricks. Same exact situation. Start with the entry at the bottom left corner. Second, eliminate A1. Next, eliminate A32. All right, so we're going to do the same thing here, but with augmented matrices. All right, okay, so let's do that. Yeah, I'm going to divide everything by 5 first. So here I'm going to have 1, -1, -1, 7, -1, 2, -3, -12, 3, -2, 7, 30. And then I do a solid line. It's just faster for me. Doesn't matter. Okay, so same things apply. Okay, hello. All right, so same things apply. Which one are we going to get rid of first? Okay. This is here too. The 3. So what am I going to do to get rid of the 3? Right, so 3R2 minus plus R3, right? 3R2 plus R3. Okay, the 3. Always the bottom right, the bottom left. Yeah. Okay, so I'm not changing these, am I? Just copy them down. The most common mistake, like we copy, when you copy, like we leave out a negative and so on and so forth. Okay, so here we're going to get a 0. What am I going to get on the next one? Almost. Okay, so what am I doing? 3R2, 3 times this, plus this one, 4. If you want to write it down somewhere, write it down. So here, 3 times negative 3 plus 7, negative 9 plus 7, negative 2. And then repeat the operation. So negative 6. Okay? Here, I did this. So 3 times this plus this. Negative 9 plus this. Okay, what am I going to get rid of next? Always. This one, the one right above it. Okay, so for that, I write down what I'm keeping the same. Now, when you get more proficient at this, we can do more than one step at a time. Like we could combine, the first two. But for now, let's take it easy. Okay, the thing with this is when you're working with this blue number, you only have one choice to work with, and that's the one right above it, right? So how can I make this a 0? Just add the two of them. So I'm going to do row 1 plus row 2. That's a 0. And then whatever I did here, I do to the other one. I get 1. Then I do to the third row, third column, and I get negative 4. And then negative 5. Okay? Right, so that was a system of equations. Now this is a matrix. Yes. I know. So now which one am I going to get rid of? The 4. And again, you only have one, you only are allowed to work with the one right above it here. So it makes it a lot simpler. So whatever you're not going to change, write it down here. Okay, now before we start, you see how here we have 4, negative 2, and 6? In this step here, you could simplify this, all right? You could divide it by 2, 1/2 times R3, right? To give you smaller numbers. You want to do that? Let's do that. So what do I get here? 2, negative 1, and 3. Yeah. In the end, it'll all divide out, but you can do it as soon as you want. Yeah. Oh, see, that's what gets you in trouble. Thank you. That's exactly what I was just saying. It happens to me all the time. It happens to everybody all the time. That's why it's important to write down what you're doing here. Okay? All right, so here, how can I get rid of these two now? What am I going to do? Multiply. Okay, so 2R2 minus R3. So 2 minus 2 is 0. Okay, here. 2R2 minus R3. Right? How much? Okay. 2R2 minus R3. How much? Negative 7. Now the next step is this needs to be a 1. So we're going to do 1 over negative 7 times R3. So 1, negative 1, 7, 0, 1, negative 4, negative 5, 0, 0, negative 7, negative 7. Okay. This now is in row echelon form. What process did we use to do this? What's the process called? It's named after that guy. What's it called? Gaussian elimination. What process did we use here? Gaussian elimination. Okay? So you can use the same for both. Okay, so now this is in row echelon form. Now to solve it, in matrices, this is always the X column, this is the Y column, this is the Z column. So the way you read this is you have 1x, negative 1y, negative 1z. Third row, 0x, 0y, 1z. So the way you convert this to equation is, from row 3, I have z equals 1. From row 2, I have y minus 4z equals negative 5. From row 1, x minus y minus z, 7. Huh? Row 3, it's 0, 0, and then 1z equals 1. X column, Y column, Z column. Here, this is 0. 1y minus 4z equals negative 5, right? 1x minus 1y minus 1z equals 7. And now, is this the same exact thing as we did on top? So you would do the same thing and you would get the same answers, you know, miraculously, 7, negative 1, 1. Okay? Now, that was Gaussian elimination. Yeah. No? We got the same thing before, no? Huh? Yeah.
Oh, wait, I read it.
We got the same thing before. We got y minus 4z equals negative 5. Here. Yeah. Okay? All right, so you see how it's the same thing but more efficient. Okay, so now, that was Gaussian elimination. What did Gaussian elimination give us? It gave us row echelon or triangular form. Now, you don't have to stop there. You could keep going. If you kept going, look at this one. If you kept going, and this is your row of ones, right? With Gaussian, we got all these to be zeros. Now, if you keep going and make all of these zeros as well, so it's ones on the diagonal and zeros everywhere else, that is called Gauss-Jordan elimination. Okay? Now, does this work for systems of equations? Yes. Does it work for matrices? Yes. Okay? For both equations and matrices. All right, so this is Gauss-Jordan elimination now. You just go further. Okay, so let's solve this by Gauss-Jordan elimination. And we're going to do it using matrices. All right, so here.
Are we going to have to know each individual one or just do the one we prefer?
No, so sometimes I ask you and sometimes it's up to you. So you do have to know, okay? All right, so go ahead and write the augmented matrix for this, please. All right, so first check if there are any, any rows that you could divide out a number, which there isn't, right? Okay, so which one do we get rid of first? Bottom left. So how are we going to do that? Multiply, right. So 2R2 plus R3. All right, so go ahead and do that and get the 0 there. Don't copy down the other rows just now. Okay, so what do we get here? 0, and then 4, 1, right? And then here, -2 plus R3 is positive 1. And then here, 16 plus this is 24. Is that right? Oh, sorry, 2R2. So 4 plus this is 12. Okay, now look at what we're going to do. We're going to combine steps here. What was the next one I had to get rid of? The second one, this one. So you know what? I can do it in the same place here, right? So how can I get rid of the 1? Add to this one, right? How can I make this -1, 0? Add it to this. So now I'm going to do row 1 plus row 2. So basically I'm combining steps because, you know, if I could minimize the steps, why not? So add the 2 of them. Now I get 0, 1, 0, 5. And then the first one, I'm just going to leave it as is. Okay? So look, what's the next one I need to get rid of? This one. How can I get rid of that one? Right, so R2 minus R3, 1, -1, 1, 3 on top, 0, 1, 0, 5 here, 0, 0, -1, -7. Is this in triangular form? It's a 5, yes. Is this in triangular form? Yes. Have I gotten it in this form? No, so I need to go further. All right, and we will go further next time. Hang on. Let me tell you which one I want you to do here. Okay, so here, do 7, 11, 19. So this is going to be due Wednesday. And then here, you're also going to do all of the P27 homework. Does that make sense?
What did you do? Wednesday?
Wednesday, because you have the test Tuesday. Tuesday, when you walk in, you need to be turning in homework.